Welcome to all in this new session. In the session from July to December, here I am starting a paper in the third sem of condensed matter physics part 2. You have studied condensed matter physics part 1 in the last semester. And in this semester, we have many properties like optical properties, electrical properties, and so many things in this. I'm starting here unit 4, superconductivity 1. Actually, this superconductivity has been kept here in two units, superconductivity part 1 and superconductivity part 2. In the first unit, we will discuss the basics about superconductivity. And in this lecture, I am introducing this subject with electrical conduction and superconductivity. What is superconductivity? This is your first lecture of this unit. This is the outline of this lecture. First, I will discuss learning outcome of this presentation of this lecture, then student effective learning outcome. Then we will move to what is electrical conduction and how can we classify the materials on the basis of electrical conduction. After this, we will discuss superconductivity and new types of materials. When we use the word recently, search means research within 50 years, then what is so important in this? Why it is used super word? What is prescript is super word? We will discuss here, and finally we will conclude with an assignment. In this presentation, we will learn about classification of materials on the basis of electrical conduction. The electrical conduction is one of the important way to classify all the materials, basically all engineering materials. We will review this in previous part of this in the beginning. Then we will discuss about superconductors, material superconductors, and some characteristics of these superconductors. We have introduced this the concept of SELO, student effective learning outcome, and we must know this. Then, if you learn this chapter, the chapters of superconductors, then this will also help you to solve problems. You can think of about the applications of superconductors. You can think how to use these superconductors in various places and how some unresolved issues can be resolved about the superconductors. So I'm using this SELO1. There is a list that we are using and provided by our university. So This falls in SELO1. Whatever we are discussing here or in this paper, it is about solid state, the physics of materials. We all know that the engineering materials basically are, most of them are plastics or metals or wood. These are materials important in daily life. The materials that we use in various purposes. Maybe natural, maybe man-made, from construction, from health, from development of various devices, and so many things, from agriculture side, from materials side, everywhere for automobiles. We are using many materials, different type of materials. They are called engineering materials. The application of these materials based on their properties, their behavior. They are very important for us because of their physical properties. We have developed many applications of engineering materials. Now, this is the era of smart materials. Smart materials which can sense easily, we can decide their behavior, we can change the behavior, that are flexible, strong, and that is the reason now it's very important to discuss about special properties of these materials. Now, in the future, in this coming era, we need new types of materials. Many properties we discuss about the solid state physics. Many properties we talk about the materials include electrical properties, the behavior of electrons in this, then thermal property about temperature, how they behave, how they react. We also discuss magnetic properties of materials. Some materials are magnetic. So we discuss this attraction and repulsion, and we discuss many applications of this. And of course, optical properties we have. So these are the behavior that we discuss for engineering materials. Out of those properties that we have discussed in the last slide, many properties you have discussed in detail in paper 1 and some other units in the paper 2 here, or you will discuss those things. But here in this unit and the coming unit, next unit, we are discussing very interesting property of some of the materials. And that is why I am concentrating only on that property. That property is electrical property, the electrical behavior. The electrical behavior of engineering materials are diverse. And so are used there, we are used these materials in electrical applications. The electrical behavior, when we use this word, this is based on electron conduction. We know that all the materials are characterized by presence of electrons in the outermost shells. The presence of electron can give you very special properties of those materials, behavior of those materials can be predicted using presence of electrons. And that is why the conduction of electron is very important for us. We have discussed many properties of engineering materials in the last slide. However, one of the most important property which is used to classify these in materials is electrical conduction. Electrical conduction basically is the movement of electrically charged particles through a medium. Here, the electrical conduction means the conduction of electrons from one part to another part within the material. This conduction may be due to a response of the material to the electric field. And we can classify these materials on the basis of electrical conduction. Broadly, the conduction is very interesting. In earlier classes, we talk, whenever we use the word earlier classes, means in the preliminary classes in the schools. First, we have started with the classification of the materials in two types: good conductors and bad conductors. Good conductors are those conductors in which electricity conduct very easily. Those materials that allow to pass the electrons called good conductors. And the bad conductors are those materials that doesn't allow electrons to move. That whenever I'm using only two type of classification, it means I'm talking about very early age. We start this work in earlier classes, earlier schooling. But when we move from there in the higher classes, higher schools, then the classification is slightly modified. As a matter of fact, not slightly, it's a major change we observe. Now we classify the materials as conductors, insulators, and semiconductors. So whenever we use the word conductors, the conductor is replaced the word good conductors. And what about bad conductors? Yes, the bad conductor is replaced by insulators. But we have added one more classification here, that is semiconductors. Those materials which are neither too much conductor, electron conduction is not too much, but not zero. It can conduct at room temperature. At 0 Kelvin, conduction is almost negligible. But at higher temperature, conduction is there. And that is semiconductors. Here, before we move to these three, I'm just introducing why I'm discussing this conduction here. The reason is, here we want to start a new unit, the unit about superconductors. So now we are introducing another classification that is called superconductors. So this is the fourth classification on the basis of electrical conduction. On the basis of electrical conduction, now we have four types of materials: conductors, semiconductors, insulators, and superconductors. Why it is super, we will discuss in the remaining slides. The electrical conductivity of a material is defined as the charge that flow through the material in a unit length. The charge that flow may be comprised of electrons, ions, holes, maybe their combinations. And one of the biggest law, one of the most important law that we use is V is equal to IR, Ohm's law, where V is the applied voltage, I is the current, and R is the resistance. We classify the material on the basis of electrical conductivity. So, as we have classified the materials into three types, conductors, insulators, and semiconductors in an old way. Here I'm discussing these classification, then we will move to superconductors. But in these classification, what we did, we classified on the basis of conduction of electrons. Those materials that allows maximum portion of applied electric field through them are called conductors. Electrons are easily moved from these materials. These materials have conductivities of the order of 10 to the power 6 to 10 to the power 8 ohm inverse. Yes, very high conductor. The conduction basically depends on electrons. However, if you talk about insulators, they can't allow the conduction. Very low conduction is possible. They do not partially allow, they can allow flow them. Electron can flow them. Electrical conductivity is of the order of 10 to the minus 10 to 10 to the minus 20 ohm inverse, it inverse. Important thing between these two is how the materials are very active to pass electrons in the case of conductors, which is not possible in the second case. However, there is another class of material called semiconductors, the solids which intermediate conductivity at room temperature. These materials allow a portion of electric current to flow through them. They are called semiconductors. At room temperature, it have very small conduction. Now the question is, if it is not conductor at all, what is the use of this? To the answer I can give, the small conduction give you new opportunities. The conduction is small, the meaning is you can control that conduction. You can use this conduction in various ways because controlling is possible. This type of controlling is not possible in conductors. And that is why the semiconductor plays a very important role nowadays. We are using semiconductors everywhere, almost everywhere in all electronic industries. Conductors can only be used to pass current, but this is used to control current, and by the controlling way you can design new materials, new devices for human comfort. There is another way to explain this: conduction band theory and valence band theory. In the case of conductors, might have studied in the last semester. Then in the case of conductors, these bands are almost overlapped. I'm not going into detail of how these bands are formed, and I'm just using this concept to explain you, to classify you these materials. In the case of conductors, there is no band gap. But in the case of insulator, the band gap is very high. The blue line he shows here is showing you the band gap. Here, the band gap is very high as compared to the conductors. Conductor, there is no band gap. But in the case of semiconductors, the band gap is moderate, very small band gap, the band gap that can be achieved by the thermal excitation of the electrons, optical excitation of the electrons. And that is why these semiconductors are very useful for us. These semiconductors play a very important role in our day-to-day life. Here we have discussed these three conductions, but interestingly, now I will reveal you another material, the material which is superconductor. Now we have discussed conductors, semiconductors, insulators. Now do this thought experiments. Yes, suppose you have two materials with you and one is A and second is B. Now you just reduce the temperature of this material. Reduce means you move towards lower side in this graph. This graph is between temperature and resistivity. You can observe this when you reduce the temperature, the resistivity also decreases this way in both the cases. First, talk about this specific case. What you are observing? You are observing a certain material which is you termed as A is having high resistivity as compared to B. So at this line you can see a material which is having very high resistance and the second one is low resistance. But if we reduce the temperature, both graph will take the same path. Same path means the resistivity is decreasing continuously. Resistivity is decreasing. A is having high resistance, so resistivity is decreasing, but still the graph is on top side. B is having low resistance, metals is there, so that metal will still have the reduction side, but the important thing is it is always lower than this. Resistance is always lower than the first one. So continuously try to reduce this slowly. What happened? Now concentrate on this. What happened here? This reason. Before that, this reason on the right hand side, if you see, then both curves are continuously decreasing. But at this place, I am writing this place as Tc. The temperature I am decoding as Tc. I will discuss this Tc word later on. But the important thing is what happened here. Where is the curve of A after this? Surprising. The curve metal which is you termed as A, the material that you termed as A is not having any curve. It shows that it suddenly dropped to 0 here. Here. The resistance is there. The resistance is higher before this temperature. But at this temperature, this material has no resistance. Resistance is 0 after that. On the other hand, the material which is having some resistance and the resistance is less than the resistivity is less than the A, still have the resistivity, not 0. What I want to convey here, the material which is at room temperature or at higher temperature is giving you high resistivity, showing you high resistivity, suddenly reduced to 0. Resistivity suddenly reduced to 0. On the other hand, the material which is showing low resistivity still have resistivity. That is very interesting concept that is discussed in 1911 by Cameling Owens. Sudden disappearance of resistivity in some materials. And that is the beginning of this unit. We are here to explain this behavior. Now you can go through these two graphs. Superconductors and semiconductors. These are another graph and the materials with resistance. Several graphs can be plotted, but the interesting thing is at TC the resistance goes to 0, and that gives you a very interesting phenomena. Some material lose all resistivity abruptly and completely at some lower temperature, specific lower temperature. The temperature is above 0 Kelvin. This phenomena is called superconductivity, and the material that exhibit this property called superconductors. The material at which this resistivity vanish is called transition temperature. Yes, we have introduced another kind of materials which have conductivity, highest conductivity or zero resistance. That is why we use this term super. You can't compare this conduction with conductors. The material which are not giving any conduction or appreciable conduction at room temperature, but at lower temperature it is giving you highest conduction because the resistance is zero. That is very important. Many metals like sodium, solid solution alloys, some ceramics, interatomic compounds gives this behavior called superconductivity, like titanium, vanadium, zinc, aluminum. Of course, the temperature is different for different materials. Now, we have shown here NBTI, NB3CSN, MgB2, then lanthanum series is there, then yttrium series is there, carbon and groups is recently given this behavior. The important thing is at certain temperature, the electrical resistance vanish and it has some magnetic flux. We will discuss this in detail in coming lectures. In this lecture, we have just introduced how the material came into picture with different properties, with extraordinary properties. Two exercises I have given here. One is explain the term conductivity and resistivity, keeping in mind about semiconductors and conductors, how this term came into picture and what is the significance of these two. Another question then I think you should work out, that is graph for semiconductor behavior at various temperatures. I've shown here graph for metals and superconductors. So what will be the graph for semiconductors? Add this graph in the same curve that I have shown in the previous slides. Do this exercise. These are the books that can be referred: Introduction to Solid State Physics by Kittel, C. Kittel, Solid State Physics, Eschoff and Mermin, Solid State Physics, Superconducting Properties of Solids by M.S. Touchless. Thank you. In this lecture, we have discussed the classification of materials on the base of electrical conduction. And finally, we have reached to a new class of materials, and very interesting class of material, that is superconductors. In the next lecture, we will talk about this superconductors, why it is so important, what are the basic things with these superconductors. Thank you.